So let's look at part B. Part B, we have the diagram shows y equals to 2x and y equals to x plus 1, and R is a finite region bounded by these two curves here. So essentially what we're looking at is this curve here. So meaning we are looking at this area here, right? This area bounded by both of the curves. So maybe I just label this out here. Now the first thing is, okay, so thankfully they have given us this point here, which is the point of intersection. Okay, so this will just be negative 1.2785, and this over here would then be 0.07754. Great. Now find the volume of a solid when R is rotated 2 pi around the y-axis, so it just revolves around this area here, giving an answer correct to 4 decimal place. So if this is 4 decimal places, please take note, just use GC to evaluate. Okay, don't really need to go through because it's 3 marks only, so you don't need to just do integration there. So let's try and understand how this diagram works. I hope you can see what's the problem here. It's actually quite a interesting shape if you can visualize it rotating about y-axis. So I'm going to just model this out for you. As you could see here, this is where the shaded regions, this is a shaded region here. So we're going to just rotate about the y-axis here, and we just have a look at how it look like. Okay, so here you go. And you will see that, okay, this looks a bit weird. This shape here, it looks like a, a hut or hat. This look more like a hat here. So we're going to use camera view. I'm going to put this as, let me see, phased out X-ray. Okay, maybe X-ray works. Okay, great. There you go. So it looks something like that. Maybe too many lines there. Smoothen the edges. There you go. Okay. So we'll get this shape here. I'm not sure whether you can see how is it like. So there's this, we need to minus off the one inside here, definitely. So this area here, we need to minus it out. So this volume here, sorry, this inner layer here, that we need to minus out. Okay, but the outer volume, which is the interesting one. So one made out from the top here, which is here to here. Okay, this top. And after which there's another one which is the bottom one which we need to consider. Okay, so the shape that you're looking at is essentially, let me just draw it out, what we want for part B. So since this is just maybe I just snip it out, hold on. So the required volume, I hope we can see all of us required volume. Okay, would be taking this shape here. So taking the green shape outer layer, so this part here, this volume here on top. Okay, so this shape here, I can just take the copy. Okay, and this bottom shape here. So this shape is like something like that. This bottom shape here. So it looks something like that, right? You can just mix them like that. And minus off the inner shape inside here. So this let me just do this inside curve here. Okay, it's something like that. Okay, so let me just there you go. So you just take these two shapes, minus off this. This case here, let's look at our model. So I hope you can see why we need to add from here to here, and the bottom part here. See this bottom here. So we integrate this line here with respect to y. You get this if just with respect to y is this strip of area here, sort of like a trapezium. Then you rotate about the y-axis is everything except for this inner thing taken out, right? So it looks something like that. This one here. Then you just add these two and minus off the here to here. Okay, so let's try and write down the integral for each of this. So the first one, this top integral here would just be from pi, it's just pi. Let us just label each. So this would be, let's say this is y1, and y2 would be, this is y2. Okay, so because this curve here is y2, so this is x2 as well. So I'm using dy, rotate about y-axis, so this will be x2 square from 0.07754. So from 0.07754 to here is 1. So because we have this over here, this is 1, this is 0.07754, that will be 1 here. Okay, so done. So I've gotten this. This is this over here would be this volume here. Then we're going to take the bottom volume. The bottom volume would then be using this curve here. This is x1. So we're just going to add pi x1 square dy. Okay. Same thing, we start from 0. So this is 0 here. Then we end with 0.07754. So because it starts from 0 here, so this is 0.07754. Great. Then the last one, which is the one which you need to subtract out, which is the one inside here. Okay, the one inside here. That will give us minus of from 0. This is 0 to 1. This is 0 to 1. So this curve here is a very simple curve, which is actually y1 is pi x1 square. This will be 0 to 1 dy. Okay. Now, but take note of this because there are two curves for x here. This is a very important part. You have two curves here. Okay. For curve here, this part here, x1 can be equals, so when you make x a subject for this, because if you look from y-axis, you actually have two equations for the x value. One is on the left tail and the other one's on the right tail. So this case here, this will be plus minus square root y equals to x plus 1. So x equals to 1 plus root y, or x equals to 1 minus root y. So this is, both are x1. So it doesn't take long for you to know that actually this curve here, the negative, because x is 1 minus, so this is 1 minus root y, this will take this curve here, right? So maybe I just label this out, x1 for this part. This will take this side on the right. So this is for x less than 1. We take this equation. X bigger equals to 1 would take this equation here, which is this part here. Okay. I know it's a bit confusing, but just follow me. Because this both x1 will use different function. Okay, so let's just write down the x1 that we want. So for this case here, pi, this is 0.07754. This is 1. x2 square would just be this. So I'm going to just make x2 the subject. So it's ln y2 equals to 2x2. x2 equals to half ln y. So this is just half ln y square dy. Yeah, so I think that's about it. Then plus the other one would just be pi 0 to 0.07754. Now this x1 here, this curve here would follow this equation, which in turn mean that we are going to use 1 minus root y square dy minus pi 0 to 1. So x1 will be here. X1 will be here. So then x1 will then be 1 plus. Okay, this is 1 plus root y square dy. There you go. So there you go. This should be your answer. I am going to just key in calculator. Just key in calculator and we'll see what we'll get. I realized I made a careless mistake in my working here. So please have a look here. This is minus. This is minus. Okay, so I'm just going to add a minus to all my equations. Minus 1 minus x. So this is minus, and the sign is still the same. What do you call it? Still the same equation, so it's fine. Just make sure to just add a minus there. So a key in calculator, this will be the this integral here. Add this both up, and minus of this. Okay, and I will get 0.559284. So this is 0. So 0. The reason why I realized I had a careless mistake is because I was having a negative volume. So once you see a negative volume, you know that something may be wrong. So negative 0.55928, 0.55928 cubic units. Okay, so this is 0.559 cubic units. Alright, so that's how, giving your answer to correct to 4 decimal places. So this is 3 for dp. Okay, so that's how I do this question here proficiently. So let's look at the subsequent part.